All right, so who's got questions? Probably gonna be a short stream today. There's three. Oh, you just got on. That's. There's three people on now, but I forgot you got on. There's four people, three people on. Oh, we're down to one. Just you. Just put something in the chat. Yeah. Oh, so we're the only three people on this. You, her, and me. No. If I don't get any questions, I may be calling this a day. Probably wait 10 minutes, 15 minutes. No takers. Call it a day. Not feeling it at all. I'll mute my microphone. Oh, there's four people on now, so somebody's here. Besides my daughter and you. You know, that one day it started out like this, like there was no questions whatsoever, and then all of a sudden it was like a lot of questions. What? Funny. I think this might be the last week of the live stream.
Coda.
Is that it? When Coda comes in, they'll start asking questions.
Coda.
Don't care. You don't care. Watch a movie tonight. I don't know. So excited. Staring at the screen. People emailing me about other week's packets. I'm really ready just to call this already. It's only been 5 minutes. In 5 minutes. Okay. Oh, here he comes. Say, wait, they're streaming. My fans need me.
Here. Go to.
Ain't nobody got questions. What? I need to adjust it. Wow. So, what are we having for dinner? Why? Take my moderator. Oh, I could remove you. Nice. I can keep. Yeah, I know. Put Alex in timeout. I think she's already logged off. We're down to 3 people. Yeah, I might as well fix the Coda cam. That's better. Look at it now. Huh? Put together the geometry and algebra 2 for next week. That won't take long. Make those videos though. I'll have to make edit those and upload them. Ah, 9.5 minutes. You say 10 minutes or 15 minutes before we call it? Alright. Like just fill it out? Not hard. Left hand. Oh, you want me to actually show you the left hand? Use the left hand to get quadrant 1. Oh. Watch. Sucking me into doing this. Have a circle. That one's about dried out.
Yep, new one's coming.
I know. We have the x and the y-axis. We know that the radius is 1. So we know that this point here is 1, 0. And then you have points 30, 45, 60. So this is 30 or pi over 6, 45 or pi over 4, and 60, which is pi over 3. Finally, week 4, day 2, number 4. I'll show you the left-hand trick. It's actually really cool. It has to do with fingers. Oh.
Oh, don't forget the green doesn't like to erase.
Yeah, let's try orange. All right. Week 4, day 2, number 4. I'm getting there. YouTube just told me I went live. It's got a little bit of a lag. Week 2, day 2, number 4. All right. So this is talking about removable discontinuities, which is a whole, meaning that if we have k of x equals, I worked this one yesterday, 5x squared plus 8x minus 21, I recognize these numbers, over 10x squared plus x minus 21. No, I did the vertical asymptote, I think, on that. Like I had the exact same problem, just different. It's just factoring. All right, so factor, k of x. I don't remember what this factors to. This was 105, negative 105. What was that? Remember? Is that right? That sounds right. I think the 15 and 6. No, it's 90. 15 and 7, you're right. So 15 and negative 7 gives me negative 105. It gives me negative 8. So then this factors, let's see, 5x squared minus 7x plus 15x minus 21 group. This has got an x in common, gives me 5x minus 7. This has got a 3 in common, plus 3, 5x minus 7. So my top factors to x plus 3, which are my greatest common factors, and then 5x minus 7. All right, then the bottom is negative 210. I think that was like 14 and 15. Yep, look at that. So this is going to be a positive 15 and a negative 14, because that'll give you my negative 210, but add to 1. I've got 10x squared minus 14x plus 15x minus 21 group. This has got a 2x, gives me 5x minus 7. This has a 3, 5x minus 7. So my bottom factors out to 2x plus 3 over 5x minus 7. Okay, now that we're fully factored, we can actually look to see where the hole or the removable discontinuity is. The removable discontinuity, or what's also called a hole, is what actually you cancel out to simplify this rational function. Because this rational function simplifies out to x plus 3 over 2x plus 3, because we cancel the 5x minus 7 out. Now, so that 5x minus 7, that's the equation to my removable discontinuity. I just say it cannot equal 0 and I solve. So I'm going to add 7 to both sides. So I get 5x equals 7, divide by 5, x equals 7/5. So that's the x value. To find the y value, we just plug it back in. No big deal. So we're going to do 7 over 5 plus 3 all over 2 times 7 over 5 plus 3. Not terrible. So this is going to become 21 over 3. No, what am I doing? 15 over 3. No. Jesus, jeez. You can tell I'm not feeling it. Common denominator is 5, so it's 15 over 5. I don't know why I keep writing 3. It's 3. So that gives me my common denominator. So 7 plus 15 is 22. So my top is 22 over 5. I'm going to write divide by. This becomes 14 over 5 plus 15 over 5, which gives me 29 over 5. Change from division, 22 over 5 times 5 over 29. Because you take the reciprocals, these cancel out to 1, and 22 over 29. Therefore, my whole, or my removable discontinuities, is the point 7/5, comma, 22, 29. 22 29ths. Easy peasy. Just factor, reduce, take whatever you take out, set equal to 0, solve for x, take the x, plug it back in your reduced function, get the y value, you have your point. 15. Right here? Common denominator. So when we add fractions, we have 7 over 5 plus 3. So you can do 7 over 5 plus 3 over 1. Multiply this way, multiply up, multiply up. So 5 times 1 is 5. 7 times 1 is 7, plus 5 times 3 is 15. That's where I got the 15 from. This is the 15 over 5, 15 over 5. I think that's what it is. Okay. What else? So the rest of them are all like that. It's just that one's a little harder because it's got fractions in it. Because I know y'all love fractions.
Same week or for day 2.
All right. This comes down to factoring again. It's special factors. The ones that are good are the ones that don't erase well. No point in fighting with it, you know what I mean?
Number 2 has difference of squares and cubes.
Yep. So you do both of those, see what cancels, take whatever cancels, set it equal to 0, and then take it and plug it into your reduced polynomial for the answer. Does he still want me to work it since he knows already how to do it? Still want me to do it, dude? All right. X squared. That means it's going to get choppy here in a second. Let me just take Codecam completely off. All right, so we have x squared minus 9 over x cubed minus 27. The top factor is 2x plus 3, x minus 3. The bottom is the difference of cubes. Yeah, see there it went choppy. Which is x minus 3, x squared minus 3, no, that's plus 3x plus 9. If you go back and look at the formula for the difference of cubes, is it still laggy? Okay. From there, my x minus 3's cancel out. This gives me x plus 3 over x squared plus 3x plus 9. I just do the x minus 3 equals 0. So my x value for my whole is at 3 when I add 3 to both sides. I plug 3 back in here. I get 3 plus 3 over 3 squared plus 3 times 3 plus 9. Gives me 6. This is 9, 9, and 9 gives me 27. 6 over 27. So my whole for this graph is at 3, 6/27. Done. Pretty easy. Yeah. Yeah, I heard him get mad. So yeah, this one comes down to really it's the bottom part here, that difference of cubes. That's why I try to give those to you on a pretty regular basis so you remember them. What else? What else? What else? He knew it by name. You know what I mean? What he had to do? Probably. Oh. Man. Kind of hard to get hype right now. I'm just kind of like, right now. Factor 3x squared plus 20x minus 63. Where's this coming from? 3x squared plus 20x minus 63. Any GCFs? 3, nope. So 3 times 63, 189. Let's see, 10, 18. So 2, 3 doesn't go into it. 4 doesn't. 5 doesn't. 6 can't because 2 and 3 doesn't. Maybe 7. Oh wait, 3 goes into that because it had to. 3 and 63. Maybe 7. 189 divided by 7. 7 and 27. Oh really? Say this is a negative, so opposite signs. So this is my plus, this is my minus. 3x squared minus 7x plus 27x minus 63. Group. This has got an x in front, gives me 3x minus 7. This has got to have a 9. Because the 7 makes 63 and the 9. So plus 9, this gives me 3x minus 7. So it factors the x plus 9, 3x minus 7. Not even challenging. That's easy enough. Once you know how to factor, if it factors, it's just a matter of finding those right terms. Yeah, no, don't ask me a question out of that book. Correct. They still get the same amount points taken off if they don't try it.
So
it's better to guess, yeah. Gotcha. If you don't know an answer, it's better to guess. Oh. You want to see the left-hand rule? So here's the left-hand rule. So okay, so here's the left hand. Right?
0, 30.
So this is going to be 0. This is pi over 6, pi over 4, pi over 3, pi over 2. In your hand, you're going to always have the square root of your number of fingers over 2. Right? Now check this out. So here's quadrant 1. So here's how it relates to quadrant 1. So we have pi over 6, pi over 4, pi over 3. This is 0, and then this is pi over 2, which is everything that's on your left hand. Now, oh, it's choppy. Now when I look at my left hand and I need to know the coordinates for 0, I hold my finger down here. Everything above is X, everything below is Y. So I have 4 fingers. What's the square root of 4? What's 2 divided by 2? So that means the X value here is 1, comma. Is there any fingers down here? 0. That's the point. We go to pi over 6. How many fingers? So this becomes the square root of 3 over 2, comma, how many fingers down here? 1/2. 1 over 2. Square root of 1 is 1. Same thing at pi over 4.
2 over 2. And the square root of 2 over 2.
And then you go to pi over 3.
Square root of 3.
1 square root of 1 over 2. 1/2. Square root of 3 over 2. 90 degrees, look, we have 0 for the X. Square root of 4 is 2. 2 over 2 is 1. There's quadrant 1. Left hand trick. Yeah. So it's just and then there's a trick for the radians to memorize them. So in quadrant 2, let me erase the hand. Because the degrees are easy. Anybody can do the degrees, right? It's just skip 30, add 15, add 15, add 30, add 30, add 15. You know what I mean?
Right.
So that's not terribly bad. But the radians people really screw up with. So if I finish this out here, so these are mirror images. So we're going to take my denominator, subtract 1 from it. What's that? So this is 5 pi over 6.
Oh, 5 pi.
This is 4, subtract 1, 3 pi over 4, 2 pi over 3. All right. So quadrant 2 is easy enough, right? Quadrant 3 is just straight down the lines. So this is pi over 3 on the pi over 3 line. Now you add 1 to the denominator. 4 pi over 3. Add 1, 5 pi over 4. Add 1, 7 pi over 6. Right? Now you have to memorize these. This is pi over 2. This is pi. Now down here, we have 3 pi over 2. It helps to memorize the axes, because there's not really a cute way of doing this. But here is your prime number starting at 3. Mirror images. So this is going to be something over 3. After 3, what's the next prime number? So it's 5 pi over 3. What's the next prime number? 7 pi over 4. What's the next prime number? 9 is not prime. 11 pi over 6. There's all your radians. There's all your radians. So when it comes to the 6s, I can get these really fast, and I just have to think of the prime numbers here. Because then it's pi over 6, 5 pi over 6, 7 pi over 6, and then I have to think, all right, it's 11 pi over 6. Quadrant 4 is the only one that has even a slight thought process to it. Because I have these memorized, so I know these radians, I know these radians here. And then once you know the hand trick, then all the 3's, the points are the same, you match up. Well, quadrant 2, we know the x's are negative, the y's are positive. And so all the 3's have the same coordinates, and then you just match up what you learned in middle school about the quadrants. God, it is like really laggy.
It gets really laggy real quick, and then it goes back to
Normal.
normal.
Yeah. There's no reason why people... There's like no reason why anybody should not make 100 on a unit circle test after I teach them all that.
Then that's just remembering what to do in each quadrant. Like the denominator plus 1. Denominator minus 1.
Yeah. And that's why, like last year when I gave it, the first unit circle test, the average was like a 70-something, 60-something. And then...
you gave it to me every week on a Monday, right?
Every week on a Monday. So towards the end, everybody was, I won't say everybody, but 99% of the people were 90 or above.
Just be a free one.
And that's why I told them it'd be a free 100. And I said, we'll go and keep doing this till everybody makes 100. And in my pre-AP classes, one person at a table would deliberately, they would rotate to miss one. So they get a free grade. Yeah. Which I'm like, whatever. If y'all want to keep taking this and memorizing the unit circle, it ain't hurting you any. Really not affecting your grade that much. So that's why, like yesterday, like the unit circle stuff, it's pretty easy to me. Calling you? Good, I want to end the stream. 30 minutes, I answered 2 questions. Playing the unit circle. Alright, so if anybody's on here, I'm ending the stream. I will be back up tomorrow at 5. I am thinking about stopping the stream altogether due to lack of interest. Nah. I don't know. I'll put a poll up on Schoology. So I'll put a poll up on Schoology, see if y'all actually find it useful. No, I'm done. Where's my mouse? A pointer. Alright.